Okay, we are in for a big one today, students. We are starting to look at the functional groups within each of the hydrocarbons. So today we want to particularly start looking at the alcohols, aldehydes, ketones, carboxylic acids, haloalkanes, esters, nitriles, amines, amines and amides, and their structural formulas. We'll look at the condensed and extended versions if we can, to be showing the arrangement of the atoms and bonding in organic molecules. So I suppose the first point we want to think about is this idea of a carbonyl functional group, and that's going to be used to separate us up. So a carbonyl group is a functional group having a carbon atom and an oxygen atom joined by a double bond, and it's found in aldehydes, ketones, carboxylic acids, esters and amides. So what are we talking about? We're talking about this here. So you can see it's found in quite a number of the groups. So if we have a look now at our diagram on the right hand side, we've got methanol. You can see that's based off what, methane, isn't it? So now methanol is an aldehyde, and it's just also known as formaldehyde. It's what they store dead bodies in. Actually, it's a preserving agent. Ethanol is commonly known as acetaldehyde, and propanone, you can see that here the carbonyl group is actually in the middle rather than at the end, and that's also known as acetone. So propanone is a ketone, whereas the others were aldehydes. So we're going to start off with hydrocarbons without the carbonyl group. So we're going to look at four in particular: haloalkanes, alcohols, amines and nitriles. So if I have a look at the haloalkanes or the halogen derivatives, we're just going to replace a hydrogen with a halogen, and so we'll get things like fluorine, chlorine, bromine and iodine, and instead of having a hydrogen there, you just got a halogen. So we're going to use bromo, chloro, fluoro and iodo as the prefixes of the hydrocarbon name. So if I have a look at, for example, chloromethane, you know that methane is what, CH4. In this case, we're just looking at the chlorine and using that as the prefix for this name. We can also call that a methyl chloride. It's generally just called chloromethane. Now, if we have a look at chloroethene, what do we got? We've just got one chloro on here. If we had two, we'd call it a dichloroethene. And if I wanted to just swap a hydrogen for a chlorine on a benzene, I will just call this a chlorobenzene. So the position of the halogen is denoted by the number of on the carbon atom it's attached to. So if there's more than one, you might go a di or a tri or a tetra. If there's four, used as a location number for each halogen used. Now, tetra obviously is only going to work for something like methane. So you've got tetrachloromethane, for example, and that's just what, CCl4. Now, if more than one type of halogen is present, they're listed alphabetically, and halogen atoms are listed therefore before the branching. So if we want to name some haloalkanes here, we can have a primary, a secondary or a tertiary type of haloalkane. Now, primary is just when the halogen is attached to one carbon and then the next carbon is not attached to any others. So let's have a look here. The carbon bonded to the halogen is only bonded to one alkyl group. Now, if I have a look here, you can see that this is a primary haloalkane because it's only attached to one of those alkyl groups here. Likewise over here. Okay, let's have a look at some others. We've got a secondary one. The carbon bonded to the halogen is bonded to other alkyl groups. So let's have a look. Here we go. So what's happening here? Here. and then we've got, you can see that we've got two other carbons over there. So let's have a look here, and what's happening, there's another one, there's another there. Okay, and then at tertiary, you get it, it's going to be 1, 2, oh sorry, if I look at this one here, how many is it attached to? Well, 1, 2, 3. And so that would be a tertiary haloalkane. So if we want to name a few different haloalkanes, we look at the top right hand corner. First of all, we can look at the first one. This is a methane molecule, but it's got a bromine instead. So we just call that a bromomethane. Now let's look at the next one. We've got two chlorine molecules, atoms, attached to an ethane. So they're two, so it's a dichlor, and they're attached to the first one, so it's a 1,1 dichlorethane. Now let's have a look at the next one. We can see that it's a butane type of molecule, and let's have a look where the chlorine is attached to. It's attached to the first one, so it's just a 1-chlorobutane. Let's have a look at the next one. It's a 4 carbons, so it's a butane, but we've got a chlorine and we've got a fluorine. So chloro comes before fluoro in the alphabet, so it's a 2-chloro, 2-fluoro-butane in this case. Now alcohols. So alcohols have this hydroxyl group. Now note that this is organic chemistry, it's not a hydroxide group which you would be used to in acids and bases. So just note that this is a hydroxyl group. It's found in organic chemistry. So the general structure is just the OH on a hydrocarbon chain, and the hydrocarbon chain is just denoted by the R there. So we're just going to replace one hydrogen with an OH group, or the hydroxyl group. So if we want to be a little bit more specific, we'd say the alcohols form from alkanes, alkanols. We're not going to stress too much about that though. What do we need to think about? We probably also should talk about primary, secondary and tertiary alcohols. So let's have a look here. We've got a primary alcohol. So what do you notice about this? A primary alcohol is just at the end of the chain, isn't it? So if you can see here, this is a primary alcohol. So that's ethanol, for example. Now a secondary alcohol, well, the carbon is joined to two other carbons. So that's going to be a secondary. And at tertiary, we've got 3 other carbons that it's joined to. So you are able to classify alcohols as primary, secondary or tertiary, seeing where those carbons are attached to. So in naming alcohols, so alcohol names follow the rules for alkanes, except for the E at the end of the parent alkanes, name is replaced with the ol. So the following rules apply. Identify the parent name from the longest carbon chain containing the hydroxyl group. So if we have a look here, here's our longest chain. And so what's that? Meth, eth, prop, bute. So it's a bute. Instead of butane, it's going to be a butanol. And you can see that it's found on the first carbon. So it's going to be a 1-butanol. And you always name the alcohols according to the closest OH group. So now if the positional isomers are possible, the number inserted before the ol to indicate the carbon in which the hydroxyl functional group is attached. Now you number the carbon chain commencing at the end closest to the hydroxyl group. In numbering the carbon chain, the hydroxyl group takes priority over the alkyl side chains. So if there's more than one numbering option, the name to which the hydroxyl group is the smallest is the correct. So note the priority then, that the hydroxyl group takes over the alkyl side group. So if we're looking here, we've got a 1, 2, 3, 4, 5, 6. So that's going to be a hexanol. Now the OH is on the third, so it's a hex 3-ol or hexan 3-ol. And then we can have a look here. What do we got here? We've got our methyl group now on our fifth. So it's a 5-methyl hexan 3-ol when we're looking at this particular molecule. Now, amines are compounds of ammonia with one or more hydrogen atoms replaced with carbon groups. So you can call them alkylamines. Now, they're also weak bases and commonly the most commonly used organic bases. So you name them by dropping the E at the end and just adding an amine. So methane amine is the simplest. So instead of methane, it's a methylamine, and it's the simplest. If there's more than one carbon chain, each is listed before the amine. So ethyl methylamine and triethylamine, for example. So if we want to name a few here, what's the first one? We've just got our ethanamine here instead of ethane. Now let's have a look at this one. The amine group is on their first carbon atom, so this is what a 1, 2, 3, so that's a propane, but we've got a amine group on it, so it's a propan 1-amine. Now this one, it's on the second carbon atom in the propene group, so it's going to be a propan 2-amine. Let's look at something a little bit more complicated. Here we have a type of butane molecule. Now we're going to note that this is a 1-amine, and that makes this a 2-methyl then. So we're going to call this a 2-methyl butane 1-amine. And so on. Now nitriles are characterized by the carbon to nitrogen triple bond. So if we want to name something like this, we've got, for example, a butane molecule. This is just a butane nitrile. Now let's have a look at this one here. This is a 1, 2, 3, 4, 5, yep, or I could go 4, 5 up there, couldn't I? Let's go this way. So what are we going to go? We know that this is an ethyl group up here, and we've got and this will be a 3-ethyl pentane nitrile in this case. Now if we look at hydrocarbons with the carbonyl group, so we've just got that hydrocarbon chain with the carbon with a double bond to the oxygen. Now we're going to have 5 main groups we're going to look at here: aldehydes, ketones, carboxylic acids, esters, and amides. So aldehydes are the first, and I mentioned formaldehyde or methanaldehyde already. So what can we see? We can see this carbonyl group, but we can also see this H as well. So we can just recall that it's a CHO, which is in particular interest, and you notice that this is at the end of a chain. So as a carbonyl group is always on the end, it's the first group and does not need a number. So we normally just write CHO in shorthand. If I want to look at some of the names, let's have a look at the first one. So instead of ethane, I've got ethanal. Instead of propane, I've got propanal. And now let's have a look at this one. I've got a butane, haven't I? So the longest hydrocarbon chain is here. I am going to name from this side, from the right hand side, so it's a butanal, and I can see that 1, 2, 3, the methyl group is on the third carbon, so this is a 3-methyl butanal. Now if I look at the next one, here's my aldehyde group here, and here's my carbon backbone. So I've got what is it? It's a pentanal, 1, 2, 3, 4, 5. and then I've got an ethyl group on the second, so I've got a 2-ethyl, and then I've got a methyl group on the third, so it's a 3-methyl pentanal. Now, ketones are similar to aldehydes, but they're found in the middle. So you can see that they're in the middle of the hydrocarbon backbone, or the carbon backbone. So the carbonyl group is not always at the end of the chain, so these group names are called alkanones. Now, we just name by dropping the final E and replace it with an one. So if I have a look here at my first one, instead of propane, I've got propanone. Instead of butane, I've got a butanone. Now, instead of pentane, I've got what, a pent-2-one. I could have a pent-3-one in this case as well, couldn't I? I couldn't have a ethanone, because if that was the case, it'd be an aldehyde. So the numbers are used to denote the carbon which the oxygen is attached to, and so in formulae we just write it as CO. Okay, when we look at carboxylic acids, I should note that you are fairly familiar with ethanoic acid. And you know that that's the characteristic ingredient of vinegar, for example. And we know that in a chemical formula, they've just got a COOH. So if we know ethanoic acid, for example, it's CH3COOH. So this is the carboxylic acid group. So what we have is our carbon, the carbonyl group, which is the double bonded oxygen, but we also have what this looks like a hydroxyl group over here as well. So when naming the final E is dropped and replaced with an OIC and an acid, so an OIC acid. So the carbon in the group is always the number 1 in numbering. So when you react carboxylic acid with an alcohol, you're going to form an ester, and an ester a very interesting group of molecules because they form a lot of flavors in our food. So for example, if I were to react propanoic acid with methanol, I would be getting methyl propanoate. If I were to react ethanol over here with methanoic acid, what would I get? I would get the ester link where they join, so it's an ethyl methanoate. So esters are a derivative of a carboxylic acid in which the hydroxyl group of the carboxyl group has been replaced with the oxygen, and it joins within the group, the chain from the alcohol. And so the general formula is COO. So we name from the alcohol side as if it's a substitute, and when naming, the final E is dropped and replaced with an O8. We'll have a look at this in the next slide. So if I want to name a few, so name the alkyl side first. So this is the word that the ester is derived from, and it's derived from the alcohol side. Now the carbonyl section of the ester makes up the second word of the ester, and it's derived from the carboxylic acid. So you change the oic acid suffix to O8. So let's have a look here. We've got an ethyl ethanoate. So what have we mixed? Ethanol and ethanoic acid. So ethanol would be this side and the ethanoic acid would be this side. So the next one is a propanoate. Oh, that's not very helpful because that's also a 3-carbon and with a 3-carbon. Okay, let's have a look at the next one, a propyl ethanoate. So what can we see here? Here's our ethanoate. So that's based from ethanoic acid, which is a carboxylic acid. And then if we look at the propyl, here's our propyl. What's happened? It's lost its hydrogen when it's reacted with the carboxylic acid or the ethanoic acid, and form part of that backbone now. So this one is a propyl ethanoate. If we look at amides, we are getting there. Sorry students, this is a huge one today, as I said, nearly 20 minutes. What have we got? We've got a carbon, oxygen, and nitrogen, and with 2 bonded hydrogen. So the amide names are derived from the carboxylic acid names. We're just going to take the oic acid and replace it with amide. So if I have a look at ethanoic acid, if I look at the equivalent, it would be an ethanamide, and that's this one over here as well, and this one. That didn't look very nice. So this one is also ethanamide. Where are we? There we go. If I want to look at propanamide, well, what do we got? There's our propane group. Now, if this was propanoic acid, it will be CHHOH. So the carboxylic acid would just have the OH replacing that bit there, which is the hydroxyl. Okay, so if I look at butanamide, instead of butanoic acid, which would have OH there, it's just got an NH2 group there, so that's butanamide. And then we've got a 4-methylpentamide. So let's have a look here. We're naming from the amide part, and then we've got on our 4th carbon a methyl group, which is here. We've done a lot today. We've looked at a bunch of functional groups, and they're going to take a lot for you to memorize. Sorry, students. And there's not much information in your data book to help you out in the test. So this is important that you memorize those. When you're happy that you'll get your head around it, you can start off with the mastery questions.